All right, in this video we're going to look at how to use gradient to help us find the equations of tangent planes. And it turns out gradient is a really slick way to do this. It's actually quicker than the formula that we used in one of the previous videos when we discussed tangent planes. In many instances, maybe not always, but pretty much, I would almost always prefer to use this gradient approach to finding tangent planes. So let me show you how this works. So we want to find the tangent plane to the surface described by this equation. All right, and we want to do it at this particular point. So this will be a point on this surface. Okay, so let's take a look at what this surface looks like. So we want to look at the surface given by x, y, z equals 1. All right, so what I'd like us to do is think about the function defined by x, y, z. So that function's domain is the three-dimensional Cartesian coordinate system. Right, so any point in here is in the domain of that function. And if I pick any point, it has coordinates x, y, z. I just multiply the coordinates together, and that's the value of the function. So this function is a little bit different than maybe some of the things we've looked at in the past, because this is a function of three variables. Its domain, it's three dimensions. A lot of the functions we've been considering are functions of just x and y. Right? So when I say x, y, z equals 1, I'm saying the value of that function equals 1. So let's take a look at setting that function x, y, z equal to different values and see what we get. Well, here's some values. So as I vary the constant that I'm setting it equal to, you can see that there are different sets of values x, y, z that solve that equation, right? And that's what we're looking at here. As I change the value of c, we see we get different solutions, and these solutions define surfaces. Now, what we want to look at is when x, y, z equals 1. So I'm going to set x, y, z equal to 1, right about there, okay? That's what we're looking at, and that's the surface that we're interested in, and we want to look at the point 2, 3, 1/6. All right, let's see if we can find that here. It should be showing. See if we can find it. There it is. Okay, right there. All right, so we want to find the tangent plane at this point. Okay, well, we are looking at the level surface for this function, right? This is setting that function equal to a constant. Now remember what gradient does. Gradient points orthogonally to the level curves, or in this case, level surfaces of the function. So gradient is something we can use as the normal vector. And so that's what we're going to do. We're going to compute the gradient of this function and use that as our normal vector to define the tangent plane. Okay, so let's do that. Here's our function. F of x, y, z equals just x, y, z. So I'm going to compute its gradient. So the gradient of f at x, y, z is going to be a vector, right? So I take its x derivative, that's y, z. I take its y derivative, that's x, z. And I take its z derivative, that's x, y. This is the gradient. So let's evaluate the gradient at this point. So I'm going to look at the gradient at those values for x, y, z. What do we get here? Well, y times z, that's 1/2. X times z, that's 1/3. And x times y, that's 6. Now remember what we said. We said this will be our normal vector to our tangent plane. Okay, so we actually have everything we need to write down the tangent plane. We have a point on the plane, and we have a normal vector. So if we remember the formula that we use for the tangent plane, right, we just plug this in. So the normal vector dotted with x, y, z is just and then we dot this vector with this point, and we get 3. And there's our tangent plane right there. Very easy if you use this approach. So by viewing a surface as a level set of a function, then we can just use the gradient to find the normal vector. A lot easier than the approach we took before, where we had to take a cross product of vectors. And by the way, I think I'd just show you what that looks like. We now can see we've got the surface, but we've also sketched that plane that is tangent at that point. And so you can see it right here.